Good morning, everyone. Buenos dias, hyvää huomenta, Ohio, and I have to learn more. Let me know if you can hear me, see me well. Let's get coding. Let's get started with coding. Happy to see you guys again here with me on a stream. Be old friends. I could say that, right? So, today, while we are getting the visuals and sounds checked, this is going to be the website we're going to be trying to recreate, or at least parts of it. Hope it's going to be fun. Hope it's going to be kind of relaxed, but let's see. You never know. Hello to Japan. And always happy to find out which countries are you viewing me from or watching me from. So let's slowly get started. How have I been? This stream is proudly powered by the Armed Forces of Ukraine. Only because of them I'm able to stream. I actually had no blackouts for past 2 weeks. And you can't believe how happy that could make a human not having any blackouts. But then, again, you get used to this so fast. Like in a week, I've completely forgot that we had a winter of blackouts. Hello to Algeria and hello to Taiwan, as always. Alright. I'm gonna switch the screen and let's start it. So this is gonna be the website, pretty cool. Go check it out. I'm gonna copy paste the URL so you could do that too. A couple of patrons and in the chat as well, people asked me to recreate this one. So let's try to do this one. Nice to see you as well. All right. Happy to see you, everybody. Okay, so I'm gonna call this one Kenta and start with the usual boilerplate file, and then desktop Kenta. Install all the dependencies. Filip Mladenovic. Oh god. Hope it's good. Have to, like, while I'm installing the npm dependencies. Well, I'm okay with this comparison. God, this is crazy. Hello to Ivory Coast. Wish I would travel someday there. Okay, we got the dependencies in. I'm gonna run the Visual Studio Code and then run the actual file. I'm gonna be using the Arc browser today. Trying to switch. Actually, I kind of like it. I'm not sure I really like the usability of the browser. I mean, the features and stuff like that. But I sure appreciate the browser having a soul, because Chrome seems to be like a soulless tool right now. You just open something in a window and that's it. And this has some human touch. And I'm slowly getting the hang of it. Okay, so this is the thing. Okay, I actually have a hotkey for arranging the windows. Right, now it's perfectly fine. And let's get started. So this is the usual template. I have a lot of stuff that I don't really need here that I always fix. And this is the plane. Let's check the plane is actually working for us. Yeah, so we have the gradient. That's okay. Alrighty. Let's get started with coding. So what about is this website actually? Where is it? It's right here. On mobile, it's a bit weird, I guess. I mean, on the like less than 1,000 pixels width of the screen, it looks a bit weird. But just imagine those as circles. So let's first use the 3D model, because this website is obviously using some 3D models. I downloaded one again. Also some images that we're going to be using. I only need the model WebP image. So let's first load the 3D model and let's see what it's going to look for us. So inside the add object function, I don't really need geometry, I don't need this. So first I'm gonna import. File was called gdn glb. Right, gdn glb, and then the import model texture equal. No, it's actually trying to guess the file name again, but the file was what was that? Model webp. All right. Alrighty. And the next, I'm gonna load this mesh because I already have the drag loader initiated right here. I believe the model is using that, so I'm gonna do yeah, kind of that, and then, well, I think let's just console log what's in there. It's always unpredictable what's inside those gltf files, so I only need gltf scene. Unexpected geometry type. What? Come again? Model gdn glb. This gltf load model. What's that about? Unexpected geometry type. Is that not a... This seems to be the glb file, and if I go there, it seems to be the glb file. Oh, come on, starting the stream with some weird errors, and this is the 3D model that I'm trying to use. Yet somehow I'm getting this weird error here. gltf loader, I'm initiating, I believe it's correct. I made in the website URL is in the chat. Just look it up again. Hello, I'm good. I'm good, thank you for asking. I'm good, but I'm a little sad because why am I getting this weird error? Maybe I should just restart the parcel or something. Or maybe it's like a cache issue, something like that. This is actually the first time I'm seeing this error in my life. So this is gdn glb, and that's correct. What the hell? Why am I getting this error? This is so unpredicted. Like some errors I can predict, but this one I can't. What the hell? Is it actually using Draco? Maybe I should just disable the Draco. Let's see. No, okay, no Draco loader instance. That makes sense. Unexpected geometry type. And I don't even need to use the model. I just do that and I get an error. Is it some update in a three.js or three.js Draco loader? Yeah, I just tried. But the error is getting on the decoding. So I can't even console log it. So I guess it's something updated in three.js or something like that. Probably. Let's try to install like the old version of three.js. Let's say this one. Or maybe it doesn't handle glb files specifically, but I actually had the parcel config like here, which is stated. So maybe it's about the update of the parcel or something. That's weird. That would be weird. Okay, and now it works. So I guess it has to do something with the three.js update, because it just worked with the old three.js version, and the current version of three.js is which one? 150 already, or 49? Which one is recent? version 150 now. So I just went back to the 147 and it worked for me. So I believe it has to do something with this, because I'm referring here they are 147, and this is a little bit of a hackery, to be honest, and I believe it stopped working in the recent version of three.js. Gotta check that out after the stream. Anyway, now we have the model. Now, what's that object in the model? This we were able to figure out the bug so fast, relatively fast. Okay, this is the group, and then the children and the mesh. Children, and then 0 is going to be the mesh. Finally, yeah. Mesh is going to be this. I'll make it slightly bigger, better to see. So weirdly, it's about three.js. Anyway, I'm going to update the mesh material, and probably mesh geometry scale set to my actual it's some weird network issue. I hope the stream is still all right. Scene add mesh. Am I getting any errors here? Mesh geometry scale set. Okay, maybe just mesh scale set. Yeah, I got it. So yeah, now it's center. Now I believe I have to scale it even more. So now we have the mesh in the center of the screen. Now to the first real hackery of this website. If you see, if you look closely at the meshes here, you're actually able to see those glowing edges. And well, the obvious way to do that for me could be using the Fresnel shader, like with the shader detecting the edges and then coloring them. But it is super weird, like super weird which way was taken by the developer here, and I'm curious to learn the reasons about it. I can only guess. Hyvä ilta to finish, friends. Okay. So the way that this one is built here is by changing the UVs. So if you remember correctly, I have the model texture right here. So I can import it to my shader. The U texture. I was really surprised when I learned how those edges are done. So just wait a minute and we're gonna see. Now if we go to the fragment shader, and we don't really have any UVs on this mesh, are we? So if I just go here, console log, mesh geometry, attributes, just to see if we have the UV attribute there. So we have the position normal. We actually have a UV attribute here, but it's all 0. So, well, we kind of have it, but we don't. So there's an attribute, but it's just 0 value. So it's the easiest way to check your UVs. Now, what I wanted to do, I wanted to check my, to change my actual UVs to something else. So first of all, let's UV equals mesh geometry attributes UV and then array. Just to check we are on the right track. Yeah, this is the 0 value array. Now I'm gonna just loop through this array, and I believe this is the number could be divided by 4 there, so I could just do something like this. UV length 4. So I'm going to be changing like values for 2 vertices, because UVs contain like double value for each vertex of the mesh. So I'm going to be changing 2 consequent vertices of my mesh here. And what I'm going to do here is UV I equals 0, 0, +1, +2, +3. So this, I believe, shouldn't change anything because I'm still making it all zeros. I think in the end, yeah, I need to update it back. So it's gonna be this, not this, just the mesh. Hello to Tijuana. Okay, so right now we just basically set in zeros with zeros. Nothing's gonna change. But what's gonna happen if I just set up 1 0 here, 1 here? Let's go back to our mesh. Don't see anything. Let's preview UVs here. I also have the test texture, by the way. Let's bring it here. This is kind of this thing. And the name of the file was test.png. Right, there we have it. So this is the UVs that we're seeing right now, because we're only changing like one of the two coordinates to some value. We only see the green. I mean, if we change this one, we're going to see the red. Right, so we're getting this weird gradient maps. Now, if we try to use those UVs to put a texture in there, let's see what's going to happen. So first of all, let's put the texture, the test. And then I'm going to fragment shader, and I'm going to do color equals texture to the U texture. This is quite a surprising hack, which has something to do with texture anisotropy. Come on. Right. So I have the U texture in place. Now I just have to set the out with this texture. So we're gonna get this weird overstretch texture. Even though the texture contains like a nice image, kind of, we're still gonna get something pretty weird in there, because we only set in one of the coordinates. I mean, we could also set, by the way, I'm just curious, we could also set something like a math random there and get really weird texture mapping there. Never done that, but I'm just curious what's gonna happen. Well, it's super trippy, because partly there's a texture, partly there's stretched. Anyway, what we actually need is this weird mapping, like this weird mapping. Now, if we're gonna use the texture, the original texture, it looks like this. It actually kind of like, what? How could you, I mean, what's gonna be with that texture? But the curious thing is that once you set this texture, nothing actually changes, but maybe, yeah, should just stretch it the other way. You could see that on the edges, we are starting to see like those white glowing parts. It's not a Fresnel shader. It's basically just mapping the texture to some weird UVs. And then on the edge, you start seeing like this. I mean, it also changes with the zoom, obviously, like it really zoom dependable, like the distance dependable, I mean, distance from the camera. So it has to do something with the anisotropy of the texture, probably the texture getting overstretched, and then some MIP maps for anisotropy are getting used, and we get this. So we get the glowing edges on the texture. That's super weird, but that works. Okay then, so next, I actually want to recreate kind of a scrolling experience of my scene. So what I want to do here, I want to render this one to some texture, and then I'm going to render my scene completely separately. So I'm going to init the whole scene again. Hey, let's do that. Yeah. Final camera. I mean, I could use just an orthographic camera at this point. Yeah, I guess that's what I need. I don't know the distance, so maybe just the near and far planes. I'm gonna set it to something like this. Then I don't actually need this. Dummy Same buffer geometry, let it be, and mesh basic material, just the red one, and then this final scene at this dummy, just to see something. So I'm gonna be rendering final camera and final scene here. And let's just check if that, what, do I have any JavaScript errors already? Init final scene is not defined because what? Yeah. So nothing changed so far, but I'm gonna switch my renderings from this. I'm gonna get all red, which is fine. And just to check that I'm working correctly, I'm gonna switch this plane to a smaller one, something like this. It's not even rectangular because I'm not using the aspect ratio in here. I could just do basically this. Okay, if it's not division, that's multiplication. This is how you figure out the aspect ratio issues. Okay, so now it's all good. Now we have this, maybe even smaller. And now I'm gonna connect the virtual scroll. Where's the npm? Let's get it. I'm gonna try to recreate kind of a scrolling and animational experience of this mesh. Okay, let's get this. And then the scroller. And then I can use an event here. And then basically maybe even here. And what I could do here is this final scene position y equals event y divided by 1000, because the values are quite big in there. And nothing seems to work for me, because why? Event. Probably because I'm intercepting the this stuff with the controls, the event. No? Oh yeah, it is. So now we can actually scroll this. It's that simple. Like if you want to create a real virtual scroll, you just copy paste this thing and you're gonna get the virtual scroll. Now I'm going a bit too far ahead. Let's bring it back a little bit. So I'm gonna comment this. Gonna get back to this later on. So now we have this mesh in the center of the screen. Let's make it bigger again. Let's also put a black background in the final scene. So this black background. Okay, but then 10. Just so it looks closer to the actual website. This black background. Yes, now I have the black background in there. I actually kind of want to render it on transparency and then set the alpha true. Okay, so far so good. So now we have just the red mesh in the center of the screen, which is not really helpful for us yet. But where's the 3D object that I'm adding? So this render target equals, okay. Basically I can use the default render target, I think. And now let's switch back to the previous scene. So we still render this mesh in here with like slight edges and stuff. So what we can do now, set render target and render this one to the texture. And then render to screen again. set null and then render to screen. So right now we're gonna have our mesh we're gonna have in the render target now. Well, hello, Marco Polo, glad to see you. Okay, so now it's kind of all right, everything, except I'm not really I have to use another shader material to use this texture, right? Because I have the render target texture now, but I'm not really using it in the final scene. So to use it in the final scene, I will need another shader. I'm gonna go here. So this is a dummy, but this material, let's call it quad. And then the vertex is basically the same. And the fragment, let's call this one quad. And then duplicate quad GLSL. In here, let's make it green so we could check that everything is working now for us. I'm going to be using the texture here again. And I need to import that one. What? So far, so good. No errors at least. I mean, the best way to start with shaders is just to write shaders. Just try to do that. The book of shaders is a good start, but then you just have to struggle a little bit. That's how learning shader goes. You just do something, make an error, learn from it. I don't think there is a short way. Hello to Nigeria. Okay. Now what I want to do, I want to use this material, newly created material. Instead of red one, I'm going to use this one. What? Okay, it's green, means it's working. And now we have a hue texture here, which is going to be null by default for the material quad. And then I'm going to set this material quad above this material. Uniforms hue texture value equals this render target texture. This should do the job, except that I'm not outputting anything yet. I also have to check if I have UVs. I'll probably have, because this is the built-in material. I have the UVs, so I can just do the same basically thing. Hue texture VUV, and then output the texture here. Okay, so we did it. So we are outputting the actual texture in here. A bit wrong with the... No, it's okay. A bit wrong with the aspect ratio because I don't really measure the screen size and stuff like that, but who cares? All right. So now we got this, and just to bring it back, can I don't actually have these controls now. Yeah. So now if I do use the orbit controls, it's going to be just changing the render target inside this plane buffer geometry. So I basically have plane buffer geometry in the center of my screen, and it's outputting the texture that I'm using. So now let's get back to the fragment quad. We're going to need another like a grain shader, I believe. That's what we need. This is one more, the grain texture that we need. This is the texture used for a little bit of a grain effect on the original website. And I'm gonna include this one now. A lot of small details, which does the final look in here. So I'm gonna import the grain from GPG, and then I'm gonna use it on this fragment quad. All right, so we have the grain. Just to check that we have it. the Copilot sometimes messes around with your code. Okay, so we get the texture. It's in there. Okay, what's next? What's next to do? So now we have to do a bit of a heavy lifting with the actual fragment shader to achieve the glass-like effect that we have on the original website, like this one. One of the main things, actually. And then the last part I'm going to do, I'm going to try to make it the scrollable experience and all the mouse interactions. Okay, let's do it with the small steps. Right. I don't actually do any resize calculations here, but you have to account for basically for all the resizing happening in the browser, just so the aspect ratios stay in the same values. The purpose is to show how to define shaders. No, I don't think so. We are trying to replicate the website that you could see in the chat, just a bit higher in the chat. Pour some tea. So thirsty. All right. So let's start doing the actual heavy lifting. So first of all, I'm going to calculate the distance from the center. So this is going to be just the distance from the center, which is going to be this, or sometimes I do this. I just like this approach a little more, but that basically returns the same value. And now, and by the way, I'm going to switch back black to something, so I will always be able to see what is happening, even if it's pitch black, yeah, something gray, just so we see the edges. All right, I'm using the Arc browser. It's kind of the new modern browser recently developed, and it's the ongoing development, but by the browser company. The company is called the browser company. Okay, so now we have the dist. Let's just try to debug all this stuff here. Dist, yeah, 0, 0, 1. Yeah, so this is the distance from the center, basically. Now what else? There are a couple of things on this effect here. So there's an edge. The edge is a little different than the, it's hard to see here. Yeah, I could see now that the edge has a different distortion here. Like it's distorted throughout the mesh, but the edge is distorted differently. It's like the edge of the glass, basically, right? There's kind of a big, huge refraction, but it's not really a refraction in this case. Or maybe some sort of simulation of refraction. Anyway, let's try to replicate this stuff. So I think it's basically like 1% or something was the value in the original shader. And I'm going to try to replicate the math from the original shader, even though I think I know how to make it in a different way, which is more understandable to me. But I'm always curious to replicate the exact steps, because this way you could learn something new, basically, and maybe use these principles in some other websites as well, and not reuse the existing ideas that you have already. So there are a couple of pretty weird math ideas used here. So first of all, we're going to change the edge distortion. Let's call it kind of out edge. And then, so I'm going to call this variable kind of an out. I'm not sure I can out, class out. And so we have the distance from the center. The distance is between 0 and 0.5 because I'm measuring from the center. So this means if I have an imaginary like radius which is equals 49, let's say, so it's right up to the edge. So just 1% of the mesh is going to be the edge. So I'm going to do then this. I'm going to create the value, which is going to be the pow of the dist divided by the radius. And let's say to the second power. And let's see what's going to happen now. So you see the black area is going to grow because all the values, all the values that are less than this radius, they're going to be below 0 for this number. And this means when you raise this number below 1, less than 1. And when you raise number less than 1 to some power, it's just getting close to 0. So if I go 20, I'm not outputting it yet, sorry. Gonna go like this. So if By the power of 2, it's going to be this, power of 1, just this. And then I think in the original, this is the power that is used there. So it almost goes up to the very edge. And then there is this 1%, which is untouched here. And then a little bit of a kind of magic function to me, which is used throughout the shaders of this website a lot. So the magnification of the kind of the distortion effect basically is going to be this. So float mag, let's call it out, is going to be equal 0.5 minus cosine, and then I think it was g out minus 1. Yeah, this is kind of a weird function, but basically what is happening here is this. So this value g out, as we already know, it's 0 almost throughout the whole mesh, and then it goes to 1 on the edge. So we only basically changing, with this we only changing the edge here. So this, of course, this will be saved, yeah. So basically what we could do here is we could output this function as 0.5 minus cosine, and then x to the power of, let's say, 2 for now, minus 1. And this is how this function looks like. It just power of 2, but what's going to happen if we raise it to the power of, I mean, at least maybe 6 for now. It just gets so many oscillations when it gets to the edge, it's just impossible. And this is exactly what this effect is for. So then we just do the 2uv out is going to be like if dist, I mean, we do the ternary operation here, dist less than radius. Kind of an interesting idea here by the copilot, but I think this is actually it. So we are adding something to the UV, or we are just outputting the general UV. So if the radius is less, I think it's just the other way around. That's it. Yeah, so we either using the default UVs or just distort them a lot. Let's see how it's going to look like. Yeah, so on the edge, you could already see kind of resemblance of this glass edge. We don't really need all the rest, which is going insane amount of oscillations. These are those oscillations here. And we could just do something if this and discard everything. So we're going to get this edge. Maybe it's better to use a smooth edge cut later on, but we can already see this kind of a thing here going on. And then the in edge. I'm going to use a G in, but in the same way, except we're going to raise it to the minus 10 power. And this means that all the numbers that are less than 1 here, they kind of go to the infinity, because raising to negative power basically means 1 dividing by this number, which means getting crazy big numbers in here. So the mag in here is going to be equal, well, the same, right? The copilot actually doing a pretty good job trying to guess. And then let's output this mag in. Let's first output the g in, just to see how is this thing all looking out yours. It's just white because it goes to infinity, but on the edge you could see that on the edge it's getting a little bit darker because it's going to the 1 and then trying to go below 0 actually. But what I'm interested in is this mag in, and it's getting crazy more patterns here, and that's because, well, the sign from the real big values oscillates a lot. So in the previous example we got this oscillation noise kind of in the outside of the circle. Now we get it inside of the circle. And I think even you could just regulate the amount of those oscillations here with basically the power in here. So even with the minus 1, you're gonna get basically just the sine effect in there. Okay, I think doesn't really matter the actual number. It's just up to you to regulate how many oscillations you want to have there. So the next thing, I want to try to use this one but I want to get rid of the garbage in here. And the way that could be done here is to use some values which are close to 0 in the center and not 0 on the outer edge. And the way the original developer did it is plot, or is it the vector 2? I think it's vector 2. The g in power is equal. Always curious what's Copilot trying to help me here. Sometimes it's just another nice idea. But we use the sine function here, and the sine function from vuvx minus 0.5, and then the same for the, oh, it is just, sometimes it's too much. So first of all, it's vuvx minus 0.5, and then vuvy minus 0.5. But I want to take the sines from this. And the reason, actually, I think in this case it could work even without the sine, but the reason I'm taking the sine is, again, if you go to the Desmos and if you just look at how the sine basically looks like, especially close to 0. I mean, sine just smoothes things out, so it's basically like a linear curve close to 0, and then it's slowly grows to the 1, not even growing up to the actual 1. When the x hits 1, it's not yet 1. You can see here it's something like 0.8, but it's kind of slow in power. I'm not yet sure, like, is it really significant, but yeah. So now the UV in, the way that it's used is actually, okay, if this is less than, let's say, like this. So if the distance is more than the radius, I'm gonna not touch it because this is the outer edge. But if it's less than that, then I'm gonna use the I'm gonna use kind of the scaling. So buv minus vec2. This is just the centered UVs, and I'm gonna multiply it with both mag in and both g in power. I have to add, like, Copilot asks me to add this thing, but it's not necessary in this case because I'm not going to be using these as an actual UVs. I'm going to just be using them as the distortion thing. So let's see how this works out for us. Do I have some GLSL error? G in power, it's actually two-dimensional. Right, so this is kind of a thing that we are getting there. This is not a real UVs. It's some value based on the UVs, some distortion value based on the UVs. It's some GLSL plugin for the Visual Studio Code. I'm not really sure I do like it. I mean, when you look at the code and the static code, it's nice. When you try to type something, it just gets in the way. And it just, even the grayed out, it's you can actually hit it. Like, you can, like, try to put the cursor in there and mess around with it. So maybe I'll disable it, because it's kind of obvious to see that this is the V0, V1, and V2. And it's not even trying to guess that this one is a two-dimensional. It just says it's the first one, the second one, and the third one. Whereas this one is actually two values here. Anyway, now we get this value. Now we can actually get the final grain. We have the grain here, right? We have the grain. Now we can calculate the final UVs. So let's calculate the UV display. Is going to be equal VUV plus plus those two distortions. So I'm going to use the UV out and UV in. UV out plus UV in. And I'm going to sample my final texture, which I'm sampling here right now, with those UVs. So basically this UV display has to be something distorted. Did I make any mistakes? UV display, VUV, yeah. It's not it. UV display. Redefinition, okay, CC, let's call it CC. So this is kind of the texture we're getting there compared to the VUV default ones. Come on, compared to the default one like this. So I guess these are too much of a distortions, but let's see what's gonna happen. So I'm gonna output this CC value, and it's too much distorted right now. So I'm probably gonna multiply this. And now we're getting somewhere, right? Starting to look like this. So you could see all those sine curve, cosine curves, or maybe sine curves in here. So these values are not actually coming from the texture or something. This is an actual sine curve, and like actual sine oscillations being kind of ported to the polar coordinates, if I may say so. And you can already see how the edge behaves. It's just like this. I believe in the final shader, actually this iteration is used. It's more like this. So basically we disregard completely all these distortions with the cosine in here, and in the UV out we are just adding the actual UVs. So it's just shifted UVs basically. Just because you could see it's not really sine distortion on the edge, it's just being rendered kind of a straight way. But it still looks nice. Let's just check for a second how it looks like on the original website. Yeah, I think so. It's more like they are straight on the edge. There's no like these oscillations on the very edge of the glass. But otherwise pretty cool. All right, and also we can add the grain here. Hello to Poland. Okay, we can also add the grain here. I had the grain in here. So what I could do, I could just add the grain RG, I think. There's only 2 color channels in that one. Multiply it with something like this. Let's make it smaller again. Yeah, let's make both of those 0 actually, just to see the grain. Yeah, this is the grain. So combined with those values. Now I don't really remember the correct values, so of course you could play with those. Now it's like super strong. The distortion is super strong right now, but why not? Okay. So I also think the inside edge in here. Okay, it seems correct. Seems correct. Right. Anyway, so this is the distortion we're getting here. Seems a little asymmetric to me, so I believe there's some values that I have to shift somewhere. Which one of those makes it? Is it the grain? Yeah, I think it's the grain because I need to normalize the grain or something. Probably, yeah, because the grain only in one direction, it's only positive values, so this one should be like this. Just to avoid the texture being shifted. Yeah, it's better now without those weird offsets on the edge, which I was trying to fix. And now it's starting to look kind of like I want it to. Now what I want to do, I want to add the mouse interactions and bring back the scroll and also add the post-processing. Oh, a lot of stuff. But it only looks like, oh, Slava Ukraini. And I only, it was hidden by the terminal or something. Only saw it now. Okay. Where do I start? Okay, let's bring back the black background. This was the black background. Here we have it now. Let's bring back the mouse interactions. Simple input events, I think it's the library that I use. Doesn't really matter which one. Bring back some mouse events. This target equals, no. Just a two-dimensional. This mouse two-dimensional. This mouse events. Then I also need the post-processing part. I might just copy paste it from some other file. And then this event on move. UVs, let's output UVs and see if it's working for us. Create input events is not defined. Oh yeah, oh yeah. Now it's defined, all good. Okay, now we have the event. I'm outputting the UVs. I need to decompose the object in there. So now I have the UV coordinate on the screen. And usually a good idea to invert the Y coordinate system. So now I have the mouse. Don't need this. Not read properties of. Yes, now we have the mouse. It's normalized, meaning it's between minus 0.5 and plus 0.5, and on both axes. Okay, that's good. And then what else? I'd like to move the scene. So this target lerp mouse point 1, and then I could set this which one? Okay, I have the final scene position Y. Okay, let's try this. Does it work? Yeah, it works kind of. Yep, and the same for the X. So basically I want this scene to kind of follow the mouse. And then I want the mesh to move in the opposite direction. So once I move the mouse to the left, the mesh kind of tries to stay in the center. And this means that this scene position X equals this means. Okay, now we could already see it's trying to stay in the spot. Do the same for the Y coordinate system. Maybe it could have moved into the opposite direction, kind of. It's like a little bit not enough movement for me, but maybe I should just zoom the original camera a little bit. That's too much. Somehow it's weirdly out of the center for me right now. This is the X and the Y. Is it me or it's not really centered for some reason? I don't know, still kind of works cool for me. Maybe it's something with the Arc browser viewport because I have this sidebar popping out here. Anyway, I think it's pretty cool right now. Pretty similar to what we have on the original website. Although it's a little bit more scaled, of course. So now let's try to add the post-processing, because it's also added in a kind of curious way, implementing the same technique, same glass technique. And yeah, let's try to do this. So you could see here we are seeing those edges. If we actually downsample the texture, the render target texture, we could actually gonna see more of those edges, like even more of those. And if we downsample it a lot, we're gonna see even more those like super sampled or something edges. Now the eyes look kind of trippy, but still you see more edges on the ears as well. All right, here. Anyway, so probably the size was a bit downsampled on the original website because it's really dependent on the distance from the camera and the sampling and a lot of factors. So anyway, by the way, I could just, instead of this geometry here, mesh material, maybe some mesh geometry, new 3. Or it's not geometry, but here like something probably like 50. And yeah, 60, 20. Will we see those edges on the torus, not geometry? That's what I'm trying to figure out. Yeah, we see those edges as well, like right here. Which is nice and interesting. Looks pretty cool though, I have to admit. Like the glass effect is really, the only thing is missing is really the post-processing. Oh, the camera is down. What the heck? Oh, now it's... I hope it's okay. I don't know what's wrong with that. Maybe the power is down. Doesn't show me. Still means we have to end the stream soon, but I'm just gonna go and copy the part of the code responsible for the post-processing. We have some post-processing here. No, not really. Which project can I copy it from? One of the last ones that I did somewhere. It has to be somewhere. Okay, I think it was here. Yeah, so I'm gonna copy the effect. I think this is maybe this one. Yeah, I'm gonna copy the post-processing effect right here. And I'm also gonna copy the code to invoke it. Was right. Yeah, just to cut the boring stuff and to get some nice look in the end. So this is the stuff that I'm copying, the effect 2.js. Where is that? Effect 2.js. I think I'm gonna copy it right here, so it is accessible in there. And then this is the actual effect, the aberration shader. And now what I want to do, want to connect that one into the final scene, and for that I need to copy the init post from the other project. It's basically similar on every project, but could have copied it from the three.js website as well. So I'm initiating the composer. I'm also getting this aberration shader effect and adding it as a sole effect pass in here. Now I could render everything with the effect composer instead of rendering it with the final scene. I'm just gonna do the composer render, and I have to set the final scene and final camera for my post-processing. Post-processing, final scene, final camera. Okay, I got some errors. This composer render, I don't run init post. Okay, we have something. I don't yet see any post-processing happening, to be honest. So I'm rendering it with composer, and this is effect 2. It's just... So yeah, we do render it with effect composer. Maybe just the values are not too big. So let's make distortion like 10 something. Yeah, we could see now some weird post-processing stuff going on here. But what I want to do actually, and the way that it was implemented in the end, was like, where's my texture? It's T-diffuse and this UV. So I could basically texture file equals... So this just outputs it as is. Now I could create 3 set of UVs. So I'm gonna create the like 2 red UV, which is gonna be equal to, they're gonna be similar but a little bit different. So this one is gonna be UV X plus sine and then normalized UV. So UVX minus 0.5. I mean, I could use the actual barrel distortion here, but that would mean that the whole edge of the circle will be of the same color. So that's why I'm trying to head for this be the original approach. RGB shift. I think this was the value. So sine value again from this is just smoothest thin out. So when it's 0, it's gonna be 0, but on the edges it's gonna grow. And what's interesting that on the like -1 it's going to be negative, on the positive side it's going to be positive, like it preserves the sign of this value. And this multiplied with RGB shift and multiplied with 1. And then the same goes for Y, but multiplied with 3. This is red UVs. Now let's go for the blue UVs. This is just one way to create the RGB shift. Those values going to be both 2. And now the green UVs, RGB, actually the green should come second. This should be green, and then 1, 3, 3, 1. So basically asymmetric, so all the colors are being shifted in different directions here. And now I could use, okay, I have some GLSL error probably, which is what? UV undeclared identifier. Okay, so I'm just probably gonna do UV equals VUV. For simplification of the code, and then line 81. Okay, now it's all good. Now I have to sample my textures. So like for R equals actually just the R, and I could take the red channel here. Now I could take the green channel for the green UVs, and I can take the blue channel from the blue UVs. But basically it's black and white, so it's the same channel. I could have taken the red channel from all of them anyway. And the final one is going to be RGB1. And that's because those are all float values now. Not only that, but something else happened. Okay. RGB1. And the RGB shift is something small. So I guess something is wrong with the camera. I'm gonna try to turn it on last time. Sorry about that, guys. The last issue to fix. Something is wrong. I don't know what exactly. Okay, I'm basically sampling stuff. UEX. Yeah, let's just try to sample everything. Okay, this way it works. The RUV. The RUV works. GUV works. UV. Okay, I'm using RUV here. So what's wrong then? Oh, I can see the mesh, but all the whites became black somehow. And that's because why? Because white is probably just the transparent color in there. Or something like that. I have no idea. I have no idea what happened. I mean, the mesh looking nice. I can already see the RGB shift in there. It's just where did my white go? Where did my whites go? UV. Okay, this way the whites are in there, but I guess I'm missing something really simple. RGB. Maybe you could spot the error here. So RGB, I'm taking the red, green, blue channels. RGB. RGB seems correct, everything, right? Maybe I could just like final error. Maybe I should just use the T-diffuse, like the final transparency. Yeah, probably because this color is just transparent, so it's not actually white. And this is the problem. Oh yeah, I can see now the problem. So this was a transparent color. So the texture that I've been trying to post-process was actually transparent. So we could only see like here this slight RGB shift. But I don't know where I missed one step somewhere, and that's why we do not have the RGB shift now on the whites. So maybe I should just do something like that. And then here, yeah. Shouldn't have gone for transparent. So now we could see those nice like glass-like effects, and also the blues and the reds on the edge of the screen. Of course, there's a little bit more post-processing going on the original website, but you could see where it's going now. And then if you just do this controls, just command this and uncomment my scroll. Basically get the, what? Oh yeah, that's because, yeah, there's a little one more step required because I'm updating those positions right here as well. So, and updating them with the scroller. Maybe I could remove it for a second, and it's actually scrolling. Yeah, a lot more steps to be taken to create a nice website from this, but hey, it's working now. Thanks for being with me. The camera is going down for some reason. I'm gonna figure out it after the stream. But that's basically it. I wanted to show you how to recreate this nice glass effect, and it's nothing too complicated on this, right? There are a couple of neat effects. The neat effect for this one, and by the way, the torus not. Yeah, we can bring back the bunny. So it's pretty cool how this achievable with just texture there, and then a texture in there, and then some weird anisotropy hack and stuff like that. And yeah. It's been some ride. Again, you never know where the bug could occur, right? Anything could go wrong. Like I just set those transparency parameters to make it easier for me, but then in the end, when I required the white color, it was just transparent color, and that's why I totally stuck. I was totally stuck. And then the issue with the three.js version, like this is the current front-end development. You never know where you could get stuck. And the only thing you could do is to learn how to get unstuck fast. So thank you everybody for being with me today. Hope it's been fun and educational for you. And let me know in the comments, and the comments help a lot. Help a lot not to like make the video more popular, probably too, but the most important thing that they help for me to do more videos and to keep my energy flowing like back and forth, this feedback loop from you. So thank you all. Hope you're going to have a great week. Say the kind words to the people that you love. Don't forget to do that. I'm wishing you a great week, and slava Ukraini. See you.